Okay guys, in this problem we are graphing cotangent of x over 2 plus 1. Now, before I do that, I need to warn you about something. See these mini eggs right here? See them? They are very addictive, so I don't recommend getting them or you will finish them in one night. So anyway, word of the wise, don't buy them because they're good. Going back, okay, now that we got that out of the way, the important stuff, let's graph this function. First off, we got to find the amplitude. I'm going to go a little bit faster on this one because we kind of talked about the amplitude. There is no amplitude for cotangent. That's why I put little quotations around it. But it can be stretched. In this situation, nothing's in front of the cotangent. Therefore, the amplitude is a 1. There's a 1 for that amplitude. Let's find the period. The native period for cotangent is actually pi. But in this situation, to find this period, we need, what's going on? Get rid of, we're still recording. Yep, still recording. But in this situation, we want to find planning hands. What does that mean? What do you think planning hands means? We want to find the new period. Excuse me. I'm sorry. I got distracted there. And the new period is determined by pi divided by b. So you just got to figure out what the b is. Now, I'm sensing that some of you are really struggling with this. See how we have this 2 on the bottom here? That doesn't mean your b is 2. That means your b is a half because the 2 is in the denominator, okay? So you could rewrite this, if that's confusing to you, you could rewrite this as cotangent of 1/2 x quantity plus 1, okay? And the 1/2 x in. And notice the b is right there, the 1/2, okay? So we're going to take this pi and we're going to divide it by, not 2, but a half. Oh, I did it by 2. Okay, I'm sorry. Pi divided by a half, and if you take pi and divide it by half, you get, and I know you might not believe me, you get 2 pi. That's 2 pi. So our new period is 2 pi. Okay. Let's find the phase shift. Phase shift usually happens on the inside of the parenthesis that's being added or subtracted. You can only determine the phase shift after you factor out what's connected to the x. In this situation, there is nothing being added on the inside of the parentheses, so there is no phase shift. That will make the problem a little bit easier. And lastly, we want to find the vertical shift. The vertical shift determined by this one right here. So we know that the function is going up 1. Okay, so we got everything we need to graph this. Now what you need to do is you need to know what cotangent looks like. What does just the basic cotangent function look like? Just like in this problem right here, we had to graph the basic tangent function. You need to know what the basic cotangent function looks like, and then we're going to modify that basic cotangent function. Well, here's what it looks like. And first off, it's right on the first page of your 14.2 notes. Okay, so let's graph y equals cotangent of x. Here, oh, stop it. To graph that, I'm going to put in some little dashes here. 1, 2, 3, 4, 5, 6, 7, 8. That should be good enough. And 1, 2, 3, 4. We'll go that way. Cotangent has a vertical asymptote right here on the x-axis. At least the native one is, okay? There's a vertical asymptote there, and it's got a period natively of pi right here. We kind of found that earlier. It had a native one of pi. So what we need to do now is we're going to make this 1, 2, 3, 4 pi. We'll make pi right here. How about that? No, we'll go out here. It doesn't matter. We'll just do this one. This will be our pi. So if that's our pi, we'll call this pi right here. And if you were to graph cotangent, I'll graph it in gray. It, instead of going from top to bottom, it goes down like this. Or from bottom to top. It's like a flip of what tangent looked like. Okay, so there it is, and then it happens again, every pi. So at 2 pi. At 2 pi. There we go. Got it. 2 pi at 3 pi at 4 pi. Same things happen. And at negative pi and negative 2 pi. We have these vertical asymptotes happening at every pi. and we got a cotangent. So it's going through its whole cycle every pi. It's like this. Okay, so this is just the basic cotangent function. Now let's modify it. Let's deal with this period. Okay, we know that the period went from it used to be pi, right? The native one's pi, but we stretched it. Right? This right over here, this 2 on the bottom, dividing by this 1/2, stretched it and made the new period 2 pi. Okay, so because the new period is 2 pi, we know that's going to do a whole cycle. See this whole cycle right here? Not in a length of pi, but a length of 2 pi. It's going to do that in a length of 2 pi. So think of everything being stretched. This whole thing is being stretched. Instead of being a length of pi, it's going to be a length of 2 pi right there. Okay. So let's see if we can make that happen. Let's see if I can delete that. Delete that. Okay. So I'm going to do this one in red. Instead of this vertical asymptote being at pi, now it's here at 2 pi. See it? And instead of this x-intercept right here being at pi over 2, and it's going to now be at pi. Okay. So notice that this kind of got shifted over from here to there. So let's draw the new one. If it goes through this point right here, the new x-intercept, it will look something like this. It comes down, goes like that. Notice this vertical intercept didn't move at all, did it? It stays there. Because it's at the 0, 0 point, you can't stretch away from being at 0. You can't stretch 0. 0 stays there. And this is going to happen again. Here's your vertical asymptote. It looks like there's a vertical asymptote every, doesn't this look like every 2 pi? There's a vertical asymptote. So if there's one every 2 pi, there'd be another one here at 4 pi. So let's put another one here at 4 pi. Okay. And there'd be another one here at negative 2 pi. So it looks like every 2 pi there's a vertical asymptote. And then every 2 pi away from this, there'll be another x-intercept. Oh shoot, Control Z that. I mean, what did I just do? File. Come on, find it. Where'd you go? There you go. Okay, so I'm not going to delete that. So this, we're going to add 2 pi to this pi to get to the next x-intercept. If you add 2 pi to pi, you get to 3 pi. So your next intercept is going to be right at this point. And it's going to go down like that. And nope, I didn't mean to erase that. Down like that, like that. You go right there. And if this is where this is, we're going to go 2 pi over this way to get another x-intercept right there at that point. And then it's going to go like that and go through and then go down to 2 pi. Okay, so what we just did here is we dealt with the period. Okay, we changed the period to 2 pi. Now the last thing we have to do is do a vertical shift up by 1. This is just, we kind of did this on the last one, right? If this is negative pi, that's 3. I would expect this to be about 1 right here and right here. So what I like to do is I like to focus on the x-intercepts, and each of these x-intercepts is going to be shifted up by 1. So it's going to be shifted about that much, right? That little smidget much. So there's going to be another x-intercept. Well, it's not an x-intercept anymore, but this intercept gets moved up there. This x-intercept gets moved up there. This x-intercept gets moved up to this point right here. So I'm going to draw my new function right here. It looks something like this, coming down. It's curving, it's concave up. Now it's concave down and going through there. See all these like bumpy points? That's bad drawing, so don't focus on that. I'm just doing my best. Here we go. Come down, concave up. Now it's concave down. It's coming down like this. Okay. And then here, concave up. Now it's concave down, and it's going down like that. So there are your final functions right here. See this one? That's your final function right there. That one right there. And then there's a good one right there at the end. So there is what we just graphed. Just to recap, we graphed the cotangent of x over 2 plus 1. It's got a period of 2 pi. Notice it's got a period 2 pi. The vertical asymptotes are at 0 plus 2 pi n. The x-intercepts are at pi plus 2 pi n. It's got an amplitude of 1. It really didn't change its amplitude. And a vertical shift up happened of 1 right there, which didn't change the vertical asymptotes, okay? So this is how you graph the cotangent of x over 2 plus 1. In the next two problems, what we're going to be doing is we're going to be graphing a secant and a cosecant function. And to graph these functions, you got to graph their reciprocals first, okay? So if you want to give those a shot before I try them, that'd be a great idea. But I will be trying them momentarily.